antigens are the kid blood group system is one of those blood group systems that are increased by that have increased activity when enzymes are acted upon them. Review question again, what are the enzymes that we use to increase the activity of blood groups or the reactivity of blood groups? Quick question lang, just for everybody's review. What are the enzymes that are used to enhance blood group antigen reactions? Somebody already answered earlier, but I'm just asking again, just to refresh everybody's minds. Hello? Uh-huh. Uh-huh. All right. Ay, Zyrene, ayan ka na naman. Advance ka talaga mag-isip, Zyrene. Wala naman akong tinatanong na ano. Thank you so much. Advance talaga mag-isip si Zyrene. Lagi na lang siya ganyan. I love it, girl. Consistent. Consistent na advance mag-isip. I love it. All right. Let's move on na, ha? Let's move on. So what are the high frequency KID antigens? What are the high frequency KID antigens? So there's three high frequency KID antigens. What do I mean by high frequency KID antigens? Well, because KID antigens, the KID system has a lot of antigens present in the if we study them all together, we're not gonna, the 8 hours that was given to us is not gonna be enough. So high frequency antigens are those antigens that are commonly seen in human red blood cells. All right. So high frequency antigens for the kid blood group systems, for the kid blood group system, they're going to ask you this in the board exam. Which of the following, which of the following, which of the following antigens are high frequency antigens? So they're not gonna tell you they're not gonna give you the kid blood groups or something like that. They're going to give you a combination of all the blood groups that we've studied here. Okay, so for example, in the kid blood group system, there are three. Okay, JKA, JKB, and JK3. Okay, these are commonly seen in the in the human population, and they are located. These antigens are located in the urea transport surface of RBCs. All right, they're located in the urea surface, their urea transport system of RBCs. And we have to talk about the kid antibodies, okay, of course. And the immunoglobulin is IgG. Okay, this is probably one of the first IgG class antibodies that we've discussed today, aside from RH. Okay, now there might be some components of IgM, but that is very rare. All right. Now, another question that will come into mind: how are they acquired? Again, when I ask how do we acquire the antibodies, I am asking, is it naturally occurring, or is it is it exposure? Does it require prior exposure? Anybody in the chat? Guesses? Guesses, everybody. I want everybody to please give me a guess. Anybody here who can give me a guess? How are kid antibodies acquired? Is it A, naturally occurring? These are naturally occurring antibodies, or B, requires uh, prior prior exposure. Sorry, sorry na dighay. All right. So I'm going to change. I'm going to add timer here. I'm gonna give you guys 15 seconds to think about it. It's okay to guess. Don't worry. Don't worry. I'm not gonna judge. You can search for it in Google if you want. 15 seconds on the clock starts now. People are starting to answer. I'm gonna look at it later. All right. I'm just gonna drink my water for a while. Okay. So people are answering. People are still answering. Okay. Glyza said occurring. Okay. Glyza, anong klaseng nag-occur? Glyza, ano yan? Ano yan, Glyza, ha? Putol. Ayan, okay, okay. Naputol si... Alright. So, naputol si Glyza. So, let us see the correct answer. They require exposure, okay, to the antithetical type. Okay, so what do you mean by the antithetical type? These two are antithetical to each other. Okay, this one here is antithetical to both. Okay, so they're not naturally occurring. They are actually going to require you to be exposed to blood. Okay, require you to require exposure to the antithetical type. All right, so what percentage of the antibodies can fix complement? Actually, 50% of kid antibodies fix complement. Okay, and the unique qualities of kid antibodies is that they are capable of dosage effect. They have dosage effect, and there is what you call what you call variable expression through time. Now, what do I mean by dosage effect? Anybody here has any idea what is a dosage effect? Jovel, Hitosis, do you have any idea what you no? Why do I think very honest? No, sir. Very honest. I love it, Jovel. What about what about Nicole Okba? What do you mean by dosage effect? Does anybody know what dosage effect is? Very honest talaga ang mga students. Wala man lang nag-guess. Alright, I love it. Okay. So I guess last one. Let's try asking Ella Villamayor. Do you have any idea what mean by dosage effect? This was discussed last week, but I just want to see if you guys are listening to me last week. Sir, hindi ko po alam. All right, wonderful. Okay, so that's not a problem. We'll try to discuss it again. So, for example, you inherit the JKA gene and JKB you inherit the JKA gene and the JKB gene. Ay, mali ang ano ba yan? Ano ba yan? Naantok na ako. Alright, sorry. So for example, you inherit both alleles of JKA. Okay? You inherit both alleles of JKA. You produce JKA, JKA. And what type of expression, phenotypic expression is this? What type of phenotypic expression is this? Homozygous or heterozygous? All right, why? Because it's the same. Now, for example, I put this one, JKB. Now, the patient's kid phenotype is like this, JAB. This is now known as heterozygous. This is homo, this is hetero, right? Now, which one do you think will have a stronger reaction in the antibodies? Will have stronger reaction to antibodies? The one that has a homozygous expression or the one that has heterozygous expression? Which one is stronger? Which will have a stronger reaction? Homozygous or heterozygous? Okay? Which of the following, number one, the homozygous one or the heterozygous pair? From what we studied before, yes, correct. The heterozygous one, because it will produce more JKA antigens. Okay? As opposed to this one, it won't produce a lot of JKA antigens. It will produce half and half. That's what we mean by dosage effect. You inherit the strength of the antibody antigens reaction to the antibody is dependent on the amount of antigens present in the surface of the RBCs. That's dosage effect. Okay? So based on inheritance, not based on the number of enzymatic activity. It's based on the number of antigens present, which is the product of the genes. All right. Now, variable expression is a little bit difficult to explain. Say, for example, you were exposed to, um, say, for example, you have, say, for example, let's use Nicole as our example. So Nicole's phenotype is JKA, and um, and we cross-matched her blood without checking her for antibodies. All right, with somebody who had JKB. She will have this blood that was transfused to her will produce will elicit what you call the anti-anamnestic response or an anamnestic response to produce anti-JKA. Ay, sorry. Sorry. Baliktad pala. Sorry. So the donor for Nicole's blood kid phenotype is JKA. She was transfused with JKB. Now, because these cells have been introduced to her body, she will produce anti-JKB. Anti-JKB. Okay? So when anti-JKB will be produced, she will have IgG molecules of it floating around her system for quite some time. What's the half-life of IgGs? Usually around around more than 21 days. Around more than 21 days is the half-life of that one. And as time moves forward beyond 24 days, the reactivity of the JKA antigens will not be will not be as strong. The expression will not be as strong of anti-JKB. And say for example, Nicole Nicole needed the date that she was that she was transfused with this blood was 2015. Now it's 2021. She will have a variable expression. So what do you mean by variable expression? As time moves forward, the strength of the reaction becomes lower. And then the next time she got it, there is memory for that one. There's memory for those cells. She immediately produces what? She will immediately produce anti-JKA again immediately. And then there's going to be hemolytic transfusion reactions. Magugulat yung mga doktor. Bakit nagkaroon ng hemolytic transfusion reaction? Akala ko compatible yung blood niya. Yun kasi nung habang tumatagal, noong 2015, hindi na siya dinouble check ng antigen antibody ng antibody screening and antibody identification. What happened is as time moved forward, the strength of the reaction became lower, but there was memory for that particular immunogen, specifically JKB. And the form of that one is anti-JKB. Now this one is no longer sensitive. This one becomes weaker, but it is still present. And the next time she got it, she immediately suffered from HTR. All right. So you guys understand what is the difference between variable expression throughout time? It means it's not consistent because one day you're not expressing the antigen reaction, but then suddenly you were re-exposed to that particular antigen, and then all of a sudden everything becomes haywire. All right? So is it easy for you to understand, guys? The variable expression or kailangan ko ulitin? Earl, gets. All right. Thank you. Let's move on. Now, what is the main clinical significance of KID antigens? The main clinical significance of the KID antigens is because of the length of time because of the length of time the hemolytic transfusion occurs. They are in they are primarily requested. They are primarily important, especially in the case of delayed hemolytic transfusion reactions. Now, delayed hemolytic transfusion reaction is another discussion that we will have today. I think this will be the last discussion that we will have today. Hopefully, we have time to discuss it. It's just a short, it's just a short one. You will see the criteria at which how a patient is how a patient's delayed hemolytic transfusion reaction is classified, and then we're going to talk about mild hemolytic disease of fetus and newborn. Why is there mild hemolytic disease of fetus and newborn? Remember, it shows dosage and it shows variable effects throughout time. And aside from that, it is mainly IgG. Okay? It's IgG. So it can pass through the placenta and still produce mild mild hemolytic anemia. Okay? So it's not that important in hemolytic disease of newborn, but it is important for delayed hemolytic transfusion reaction because of the anamnestic response. All right? So we're not going to delve deeper into that. There's no other things that we need to discuss about it. We're going to move on with the MNS system. Okay? So the MNS system is another one that is important in your exams because this one is inactivated by enzymes. All right? So they are carried on glycolipids. Glycophorin in the glycophorin molecule of the RBCs. And they're like this. There are two types of glycophorins in the human body. Okay. And the first one is for glycophorin A. First one is glycophorin A. Okay. Glycophorin A and glycophorin B. Now each antigen has a different designation for that one. The MNN antigen is for the MNN antigen is for glycophorin B, glycophorin A, sorry. The MNN antigen is for glycophorin A, and for glycophorin B, it's the N, is the S, the big S, the small s, and the U, right? So that is the antigenic designation of the MNS antigen. So, sir, sino naman to si you? Akala ko ba MNS lang ang pinag-uusapan natin? Pinaglololoko mo ako, sir. No, hindi kita pinaglololoko. You will find out later. Alright? But first, you need to know that the last five amino acid residues in um, in glycophorin A is responsible for the antigenic uh, activity of these two antigens. And for um, for the M antigen, it's it's glycine, threonine, serine. And then for N antigen, it's glutamine, threonine, serine, leucine, which is which makes these two things, which makes these two antigens differ from one another. This is summarized here. It's actually a long chain of amino acids, but the last five is actually the most important one because it is read by it is important because it is the one that is the antigenic portion or the immunogenic portion of these two antigens. Now, the big S and the small s antigen is a component of a larger molecule in the glycophorin B. This is actually known as your U antigen. The U antigen is the one that carries the U antigen is the precursor or the base molecule for the S antigens. Okay, the small and the big S antigens. Now, the only difference between them is that at some part of the glycophorin B, particularly in the U antigen, what makes them different is that both of them structurally are the same. They're both U antigen. But what makes them differ from one another is that for the big S, the glycophorin B structure or the U antigen for this one is going to have methionine at the at any portion of the stalk. All right. The small s will have threonine or TRH, threonine at any portion here. Okay, both of them are made up of the stalk of U. But what makes them different is the structures of is the residues. All right, methionine for big S, threonine for small s. Okay, easy, easy, easy. Now, let's compare the frequency of the following in the general population. M and N are considered to be as equally distributed among the general population. Okay, and let's compare the S and the big S and the small s antigen. The small s is actually seen in much greater frequency than the big S antigen. Okay, so it's greater than S. Now, the SSU phenotypes, S negative, big S negative, and the small s negative, and the U negative phenotype is seen in what ethnic groups? Not U antigen, sorry. African Americans. Okay, sorry, the answer is African Americans. And then which MNS antigen is the highest frequency in the general population? Sorry, Caucasians rather, Asians rather. The answer to this one is for Asians. What happened to that one? Sorry. Answer to that one is Asians. Let me double check let me double check what happened to the slide. Okay. What happened? Okay, so it's Asians. I'll just add. Okay. All right, it's seen in Asians. Okay. And now, which antigen of the MNSS system is in high frequency in the general population? It's of course the African Americans. All right. And the plant that produces anti-N activity. I think this was a question from last week. Well, last week's Kahoot. It's Vicia graminea. Graminea. Okay. Vicia graminea. All right. Now differentiate the MNS antibodies based on how each are acquired. Differentiate them. So M, N, S, S, U are acquired how? Which one is naturally occurring? Which one is going to require prior exposure? Answers? Anti-M and anti-N are naturally occurring, while anti-S, the big S, the small s, and the anti-U requires prior exposure. Now, complete the table. Which of the following has complete the table? What is the immunoglobulin class? I think we just need to hurry this up because we're going to run out of time if we don't hurry up. Great way for you guys to remember. Both of these two are together, okay? And since it's a companion of M, way for me to memorize it is M here, IgM predominantly, okay? They both predominantly IgM. And the rest is G, okay? So that's the answer to that table. All right, let's go to the clinical significance. M and N, since they're naturally occurring, they're usually insignificant clinically. And the S and the big S and the small s and the U antigens are the ones that are significant. Okay? Now, dosage. Which of the following shows dosage? Which of the following shows little to no dosage? Easy to understand, easy peasy. It shows dosage if this is going to be the first two. Okay? Okay, shows dosage. This one, no dosage. These three, no dosage. Okay? Now, All MNSSU antigens are deactivated by enzymes except for the U antigen, right? All of them are cleaved except for the U antigen. All right, so there are peculiarities about the MNSS system. You need to take note of this. Um, the glycophorin B variant of GPA or glycophorin A. This one is the glycophorin B variant that possesses antigenic activity to N. This one basically is a variant of this that possesses that GPA possesses the antigenic activity for N is basically the N-like antigens. Remember, GPB is usually for S, small s, and U. But it becomes a variant that has similar qualities, antigenic qualities to GPA, and it also has a N activity. That's that's going to have N antigens. The other designation is prime N prime. All right, prime N prime. That's another uh, that's another way to express this one by nomenclature. Now, true or false? A person who has N-like antigen but is phenotypically M positive, N negative will produce anti-N. A person who is N who has N-like antigens but is phenotypically M positive, N negative will produce N. Answers? True or false? We'll double check later to see and I'll give you guys the explanation. 15 seconds on the clock. Is it true or is it false? All right. I want people to, it's okay to guess. We'll try to answer. Okay. Glyza was the one who answered first. All right. What about the other people? Glyza is the only one. John Mediana also trans. Okay, okay. Ina answered true as well. Walang magsasagot ng false. Kung gusto ano. No, I believe my answer is false. Walang gaganon. In my opinion, walang gaganon. I would like to talk to your manager, sir, because this one is unacceptable. Mga ganon. False? Ayan, si Earl Palmero. Ay, naku, ayaw ko talaga yung may question mark na yan. It means you're just guessing. You're not critically thinking. Let's try to extrapolate some information from the previous slide. Okay, critical thinking skills. Normally, GPB or glycophorin B is used for the SSU antigen, right? Tapos na yung timer eh. And it becomes a variant of GPA and it shows N activity. All right. This phenomenon occurs because there's a sort of mutation in the there's a sort of change that occurs in the patient. Okay, and when this occurs, it has a similar activity, but the antigenic structure is not the same. It's still glycophorin B. Remember, what is the N like? What did we talk about earlier? It has to have the five characteristic molecules that we have: glycine, threonine, serine. This one, the problem is somewhere here, not the last five. Okay? That's your normal. That's your N, ano. That's your normal N antigen. Tama ba? Tama ba yung structure ko? Sorry, double check ko lang. Baka nagkamali ako. Double check, baka nagkamali. Ay, sorry. Glucine pala. Glutamine pala. Glutamine. Sorry. Okay, so glutamine dapat. glutamine, threonine, serine, serine. Last one is serine, threonine, serine. Yeah. So yeah, yung last one, paltan. All right, so that's what happens. The problem is the inner portion of the glycophorin, still the same structure, and therefore it will not produce anti-N. It produces only anti-N like antigenic structure. N like. So the correct answer is false. It just mimics the determinant antigen, but these people will not produce anti-N. So actually, the only person who answered correctly is Earl. So, kalain mo yon, yung hula mo na may smiley face pa, tumama ka, Earl. Kalain mo yon, lahat sila sagot nila true, 'di ba? So it pays to be different pala in this kind of situations. All right? Now, let's talk about autoantibodies formed by patients who are undergoing hemodialysis. So, the autoantibody that we're going to talk about is auto-anti-N. Formaldehyde, the formaldehyde from the sterilization process causes the formation of autoantibody due to the modification of N antigens. All right, so it becomes non-self. So it sort of denatures the N antigens that we just talked about earlier. Okay, and it causes the formation of autoantibodies. All right, now let's move on to the Duffy system. Now the Duffy system has a couple of main antigens that we need to talk about. Um, there's only two, actually, not a couple. The FYA and FYB. Easy to remember because it's FY, Duffy, the last two letters. Okay, so the FYI antigen that is what Duffy antigen is high frequency. It is actually um, so the high frequency one for Asians is Duffy A, denoting for Asian race, AA. For Caucasians, it's Duffy B. Okay, now for African Americans, it's actually the null Duffy phenotype, or no Duffy. Duffy. There's no Duffy or at all. It's just FY, FY. All right, or this one. Depends on how you want to type how you want to type the genotype of the patient, the phenotype or the genotype. All right, now let's talk about the how many. Let's talk about how many percentage of the African patients will exhibit this phenotype. It's about 60%. Sorry, it's about 68%. And we have to talk about the autoantibodies for Duffy. Duffy antibodies actually have the same characteristics as that of the KID antigens, and they also cause delayed hemolytic transfusion reactions. All right, so KID antigen, Duffy, so on and so forth. Both of them will have the same reaction. There are both reactions at the same time. Now, let's talk about the peculiarities of the Duffy system. The patients with Duffy negative Duffy A negative, B negative phenotypes are considered to be resistant to what? Ayan. They're considered consistent ko sorry. A patient with nakakangongo kasi yung FY na yan eh. A patient with Duffy A negative, B negative is considered to be resistant to what? Parasitology ulit. It's another parasitology question. Mabibigyan ko kayo ng choices. Ay, may sumagot. May sasagot ata. Sige, sige. Ayun. Ayun. Congratulations. Somebody answered correctly. Thank you so much. So these people are malarial. Why is there malarial resistance for these patients? Because these patients lack the Duffy antigen. Both A and B are actually receptors for the malarial merozoites. Okay, they're malarial merozoites. Now, let's move on to the Lutheran system. Now, the Lutheran system is another group of antigens that we need to talk about. And there are two antigens of interest, LUA and LUB, or LUA, LUB. The high frequency one is B. Okay, high frequency one is B. Now, what is the most common Lutheran antibody encountered in the lab? It's actually LUA. Really, sir? Yes, because it's B. We usually have it in the general population. It's high frequency in the general population, and therefore the antithetical one, since you don't have LUA, you will produce anti-LUA, okay, or anti-Lutheran. Gets nyo? Kung bakit siya yung pinaka-common na Lutheran antibody? It's also naturally occurring, right? And the immunoglobulin class is IgG, but they are rarely clinically significant. Now, in my board exam, to be honest, this was asked. This was asked in my board exam. Which of the following antigens is not a high frequency antigen or is a low frequency antigen, if I'm not mistaken? And Luther, sorry, if a high frequency antigen was the one that they asked, and I remember I remember it as if it was yesterday. I answered Lutheran A, and up to today, I can still remember I made that mistake. All right, now what's the most common Lutheran antibody encountered in the bat? Yeah, I've already answered that one. They are rarely clinically significant. Let's talk about KL antibodies now. Now, KL antibodies are divided into two groups, the high frequency group and the low frequency group. The first group, the KL antibodies are, there's two types, big K and small k. One is low frequency, one is high frequency. Another name for that one is K1. Big K is K1, small k is K2. So just to avoid confusion, for the purpose of this discussion, we're going to refer to the KL antigens as K1 and K2. Okay? So low frequency is K1, high frequency is K2. All right? So how do we remember? Basically, when you write the K in your alphabet, the first one that you're going to write is the big one. The second one that you're going to write in the alphabet is a small one. So it's easy to remember. All right. So what are the other KL antigens aside from K1 and K2? So we have a lot of them actually. We have we have JSA, okay, NB, KPA rather, KPA and B. Now, which ones are the high frequency ones? The high frequency ones, the high frequency ones are the B ones. Do you notice a trend, class? Do you guys notice a trend? Most of the high frequency antigens are in the B side. Napansin nyo, class? Almost all of them are high frequency if it's in the B phenotype. So please be mindful of those ones. Okay, all B's are high frequency antigens. So even in the kid antigens, the Lutheran, it's still the it's still um it's still the B one that's high frequency. So until Kel, it's always the B's that are always positive, and that is always high frequency. Now, this is an antigen that closely resembles K antigens. It's actually KS, KX, okay, KX. This is the most immunogenic non-ABO RH antibody, and that is anti-K or anti-big K or anti-K1. Actually, when you plot together the reactivity rates, the first one will be the ABO always significant. And next to that, the third one is the KEL antibodies. Okay, specifically anti-K1. All right. So the clinical significance of anti-K1, it is capable of causing severe hemolytic transfusion reactions and hemolytic disease of newborns. All right. So what are the characteristics of anti-K? Well, similar to anti-K, they have similar characteristics. However, they're very uncommon. Okay, so anti-K, small k, or K2, it's very uncommon to encounter this. Now, let's talk about the peculiarities of the blood group, KEL. KX and K and the KEL antigen are closely related blood groups. True or false? This is actually true. KEL and KX needs to be at equal expression on the RBC surface. Otherwise, a disease state can occur. It's actually true. And we're going to talk about the disease states when there is unequal concentrations of KEL and KX antigen. So for example, we have what you call the MacLeod phenotype. Now the MacLeod phenotype is going to have low expression of KL antigens and low expression of the KX antigens. KL null, on the other hand, is either a low expression or no expression of the KL antigens. Hence the term KL null. But there is a high concentration of KX antigens. So see the difference? Both are low for MacLeod phenotype. For KEL-null, all KEL antigens are decreased except for the KX antigen. All right. Next, what antibody can be seen in patients with KEL-null? So because patients of KEL-null don't have the KEL antigens, they're going to suffer from what you call anti-KU. KEL-null nga eh. Wala talagang kahit anong KEL antigens, whether it's JS, JB, something like that. So it's U stands for KEL universal. Okay, so what antibodies can form from the patients with MacLeod phenotype? MacLeod phenotype, low expression of anti-K, low expression anti-K1, and low expressions of this one. So it's going to produce anti-KX and anti-KM. What's the M standing for? Anti-MacLeod. All right. The patients with the MacLeod phenotype syndrome typically have what blood film finding? They usually have acanthocytes. What's an acanthocytes? Just a review from last month's lecture. No, not last month's. October's lecture. I think I was the one who delivered the hematology discussion to you guys. Is that correct? Am I the one who delivered the hematology discussion? Okay, okay, sure. So, acanthocytes. So acanthocytes are a little funny. They have these spicules. Okay, they're also known as Burr cells. Okay, and we're going to move on with the Diego system. The Diego system is built on what part of the RBC? They're built on the band 3. Band 3. What's the importance of band 3? It's actually a cytoskeleton for the RBC molecule, for the RBC surface, for the RBC shape. Okay, band 3 structures. We have band 2, band 3, ankyrin. There's a lot of things there. If you review your hematology class, this one will be mentioned several times. All right, so how many antigens are included in the Diego system? There's actually 20, but we want to study only two antithetical pairs. We have the DIA, NB, or the WRA or B. Okay. Now let's talk about the frequency. So let's look at it again. do you think it still applies that the B one are the high frequency antigens? Let's double check. Yes, it still applies. Okay, so it still applies. The rule of B is usually the one that will have the high frequency antigen seen in the general population. And I guess that's it for our discussion for this particular lecture. Now we're going to move on with transfusion reactions. Um, if we have time, I will teach you guys how to do antigen antibody identification. All right. So since we got 45 minute